Yeah, welcome to this short demonstration of the Texas Instrument AWR1642 radar demonstration sensor. We are operating the sensor here in a typical automotive application, and we would like to show here some typical analysis that can be done with the 2760A and this kind of sensor. So first of all, we are setting the analyzer to the center frequency of 77.284 gigahertz. This center frequency has been known beforehand. We are switching then into the so-called zero span operation, because first of all we would like to get an overview about the frame periodicity and the chirp frame time. Remember, these are essential parameters that we have discussed beforehand. We are going to a level of minus 20 dBm. We are switching on the IF gain. So here we can see already some incoming pulses. Let's adjust a little bit here the y-axis scaling so that we see it in a better way. And if we are now switching over to sweep time of 100 milliseconds, we can clearly see here the different chirps of this automotive radar that are coming in. So let's now go into the trigger mode in order to make some measurements. So first of all, we are going into the trigger mode. Let's switch off here, or switch on a hold off of 66 milliseconds in order to limit a little bit the number of incoming trigger pulses. We are going to video trigger source. Let's use here a level of minus 40 dBm. And let's use here negative trigger delay of minus 5 milliseconds. So we are getting now here a stable readout. We can see here the chirp time frame. We can see here the so-called frame periodicity. And we would like to fill these figures with some real measurements in the following. So we are going to a sweep time of 40 milliseconds. We are applying here some kind of trace averaging to get the readout a little bit stable, more stable. We are switching on marker 1, and we are putting this to 0 microseconds. Now we are switching on marker 2, and we are adjusting marker 2 in a way that we can measure here really the chirp time frame. So this is around 15 milliseconds. We are switching on marker 3. And with marker 3, we would like to measure the frame periodicity. And this is the essential figure that we have to use later on in order to do some channel power measurements on the radar itself. So we are getting here 33 milliseconds. Now let's apply some delta marker settings here. And marker 3 is also delta to marker 1. And now we can switch on the so-called marker table. And we see here a chirp time frame of 15 milliseconds. We see a frame periodicity of 33 milliseconds. So these are the essential parameters that we need to recap later on if we are going back into the frequency domain in order to measure the channel power of this device. So let's Now continue, and in the next we would like to get a feeling about the average power that we can detect here in the time domain. We are resetting therefore our markers. We are disabling again the trigger, and now we are setting a quite long sweep time of 10 seconds. And now let's wait for the first incoming measurement readings. This means by applying such a long sweep time, we are essentially averaging the received power more and more and more. This is kind of linear averaging, and we will see later on that this figure is corresponding and quite nice also with the figure that we can measure in the frequency domain mode. Let's really check that we have here selected on the detector peak. And now let's switch on the marker. We can read out here an average power of, now let me say, minus 29 dBm. Okay, so now let's continue and go back into the so-called frequency domain. We are going back here into the normal operation mode. We are setting our sweep time again to 100 milliseconds. Frequency, last span. This takes now a while until the analyzer has switched his operational mode. And to make it quite easy, I'm just loading here. So we are loading here the so-called configuration number 2. And now we have to wait a little bit. You see, we are having applied here a sweep time of around 65 milliseconds. Remember that the frame periodicity was 33.3 milliseconds, and this is the minimum sweep time that we need to apply so that the measurements are taken long enough in order to average out essentially all the chirps and the duty cycle of the chirping radar. Let's check here on the bandwidths what kind of resolution bandwidths we are operating, 3 MHz and also 3 MHz video bandwidths. And the VBW type is linear. This means we are getting here the linear average of the incoming power. And now let's go into the measurement mode, and we would like to get a feeling about the occupied bandwidths and the channel power. Let's wait until a complete sweep has been done, and then the green dotted lines are getting updated and the below fields are filled up here with measurement results. So a complete sweep has been passed, and we are getting here as a result an occupied bandwidth of 513 megahertz, and we are getting a total received channel power of minus 8.87 dBm, so approximately minus 9 dBm. The measurement distance between the MS2760 including this dielectrical lens antenna towards the radar is 1.35 meters, And if we are considering here at the 77.284 gigahertz frequency, a free space path loss of minus 73 dB, then we will see later on in one of the next slides that all these figures are coming well together, and the theory and the practical measurements are more or less equal. So easy was it to measure, first of all, in the time domain, the chirp time frame, the frame periodicity, and the latter figure is essential to get a stable readout later on for the channel empowerment. Thank you for watching.